Imagine a world where every single volcano erupts at once. What would happen? This is not a plot from a science fiction movie, but a hypothetical scenario we're going to explore today. Our planet is home to around 1,500 active volcanoes, each one a powerful force of nature. Consider the eruption of Mount St. Helens in 1980, which blasted more than a cubic mile of Earth into the sky, or take the Krakatoa explosion of 1883, its sound heard 3,000 miles away. Each eruption is a display of the raw power of our planet, a testament to the volatile world beneath our feet. Now imagine the energy, the force, the sheer magnitude if all these volcanoes were to awaken together, to share their fiery breath with the world all at once. What would be the consequences? But what if all these volcanoes erupted simultaneously? Let's delve into the science. To understand the impact of all volcanoes erupting at once, you first need to grasp how a single eruption works. Let's begin by digging into the heart of a volcano, the magma chamber. This is where magma, a hot, molten rock from the Earth's mantle, collects. When pressure builds up in this chamber due to an influx of magma, or tectonic activity, an eruption can occur. Tectonic activity, you ask? Yes indeed, the Earth's crust is broken into large pieces, called tectonic plates. These plates float on the semi-fluid layer of the mantle below them, and their movement can cause a lot of geological drama, including earthquakes and, you guessed it, volcanic eruptions. When plates collide, one often gets pushed under the other, a process known as subduction. The subducted plate melts in the mantle, forming magma. If this magma finds a weak spot in the overlying plate, it can force its way to the surface, resulting in a volcanic eruption. Now, not all eruptions are created equal. There are two main types: effusive and explosive. Effusive eruptions are the less dramatic of the two. They occur when the magma is low in gas and silica content. This makes the magma less viscous or more fluid, allowing it to flow out of the volcano relatively peacefully. Think of it like pouring syrup on your pancakes. Explosive eruptions, on the other hand, are the real showstoppers. These happen when the magma is high in gas and silica content, making it more viscous and sticky. The gas gets trapped in the magma, building up pressure until it blasts out of the volcano with incredible force. This is the kind of eruption that can send ash and debris thousands of feet into the air and cause widespread destruction. Now that we understand the mechanics of a volcanic eruption, we can assess the repercussions of a global eruption. The immediate effects of a worldwide volcanic eruption would be catastrophic. Imagine a scene where the ground begins to tremble beneath your feet. Suddenly, every volcano on Earth rumbles to life, spewing smoke, ash, and molten lava into the atmosphere. The sky darkens as ash clouds blot out the sun, creating an eerie twilight at midday. One of the most immediate effects of this volcanic apocalypse would be the release of ash. Volcanic ash, unlike the soft, fluffy stuff left in your fireplace, is hard, abrasive, and often filled with microscopic shards of glass. It's heavy enough to collapse buildings, toxic enough to poison water supplies, and if inhaled, it can cause serious respiratory problems. And then there are the pyroclastic flows. These are fast-moving currents of hot gas and volcanic matter that can move at incredibly high speeds, up to several hundred kilometers per hour. Nothing can stand in their way. They demolish everything they touch, from trees to buildings, and are lethal to all forms of life. Lava flows, while less sudden, are no less destructive. They can engulf entire towns, setting structures ablaze and leaving nothing but a barren, smoldering landscape in their wake. The seismic activity associated with these eruptions could also trigger tsunamis, massive ocean waves that can reach heights of up to 100 feet. These waves can devastate coastal areas, sweeping away everything in their path. The potential loss of life would be unimaginable, and the destruction of infrastructure would be immense. Roads, bridges, airports, power plants, and entire cities could be wiped off the map. The world as we know it would be irrevocably changed. But the immediate effects are just the beginning. The long-term impacts could be even more devastating. The world would be plunged into chaos, and we'd be left to grapple with a drastically altered climate and a severely damaged ecosystem. But more on that in our next scene. The aftermath of a global volcanic eruption would drastically alter life on Earth. Imagine, if you will, a world changing before your eyes. The long-term effects of a global volcanic eruption would not just be immediate and catastrophic, but they would also alter our planet's future in ways we could hardly fathom. One of the most significant effects would be a massive shift in our climate. Volcanoes emit a variety of gases, including carbon dioxide, one of the primary greenhouse gases responsible for global warming. With all volcanoes erupting simultaneously, the amount of these gases released into the atmosphere would be colossal, leading to an accelerated rate of climate change. Yet, paradoxically, we would also experience a decrease in global temperatures. This is due to volcanic ash and sulfur dioxide particles blocking sunlight. These particles form a layer in the Earth's atmosphere, reflecting back the sun's rays and causing a cooling effect, a phenomenon known as a volcanic winter. This significant drop in temperature would have a devastating impact on global ecosystems. It could lead to widespread crop failures and famine, as plants would be unable to photosynthesize without sufficient sunlight. Consequently, this would disrupt food chains, impacting both wildlife and human populations across the globe. Additionally, the sulfur dioxide released by the eruptions could result in acid rain. This rain could further damage ecosystems, harm wildlife, and contaminate fresh water sources. The acid rain could also corrode buildings and infrastructure, leading to long-term societal challenges. It's essential to understand that these changes wouldn't just last a few years. The effects of such a vast amount of volcanic activity could linger for decades, even centuries. This would be a world vastly different from the one we know today, a world struggling to recover from the devastating effects of a global volcanic eruption. A global volcanic eruption could plunge the Earth into a volcanic winter, leading to a mass extinction event. The long-term consequences are sobering, reminding us of the immense power held beneath our feet and the delicate balance that allows life on Earth to flourish. The question remains, is a worldwide volcanic eruption actually possible? This is where science steps in. According to volcanologists, the probability of all volcanoes erupting simultaneously is astronomically low. This is due to the fact that each volcano operates on its own cycle, independent of others. Some may remain dormant for centuries, while others might erupt multiple times in a decade. Yet, let's consider the Yellowstone supervolcano nestled in the United States. This beast of a volcano has the potential to cause a global catastrophe all by itself. Its last eruption, over 600,000 years ago, spewed enough material to bury states like Texas under 5 feet of ash. The resulting climate shift would have had worldwide implications. So, while the simultaneous eruption of all volcanoes is extremely improbable, even a single supervolcano eruption could have dramatic global consequences. While highly unlikely, the thought of all volcanoes erupting at once is a humbling reminder of nature's power. From the immediate devastation to the long-term environmental changes, the impact of a global volcanic eruption is almost unimaginable. In the last few minutes, we've journeyed together through the raw, awe-inspiring power of volcanoes. We've delved into the science behind their eruptions, explored the immediate and long-term effects of these geological phenomena, and even pondered the plausibility of a worldwide eruption event. We started our voyage with the power of volcanoes. These sleeping giants are not just natural spectacles, they are potent forces that can reshape landscapes, create new land, and even influence the climate. We then navigated the science behind a volcanic eruption. It's not just about magma and lava, it's about the immense pressure buildup from the Earth's mantle, the catastrophic release of this pressure, and the subsequent ejection of ash, gas, and molten rock. Next, we grappled with the immediate effects of volcanic eruptions. We've seen how they can obliterate entire towns, cause tsunamis, and even bring air traffic to a standstill. The long-term consequences were no less unsettling. From the significant drop in global temperatures to the potential for years without summer, the aftermath of a global volcanic event could drastically alter life as we know it. Finally, we asked the burning question, can it really happen? While a global eruption is technically possible, it's an event of such low probability that it's more valuable as a thought experiment than a real concern. Through this exploration, one thing is clear: we must respect the power of nature. While we can study and learn from these powerful geological phenomena, we can never fully control or predict them. It's a humbling reminder of our place in the grand scheme of things. Volcanoes are not just mountains. They are dynamic and powerful systems, a testament to the energetic and ever-changing nature of our planet. So, next time you see a peaceful mountain, remember the fiery potential that lies beneath.